A very good afternoon to all the delegates present here. First of all, I would like to thank the organizing committee for giving me this wonderful opportunity to present a paper titled Optimization of Supply Chain System using ML Algorithms. A paper title is 2023-128 and authors are Shriyash Band, Aditya Pokharkar, Anish Dhwalikar, Himang Tyagi. And this research paper is under the supervision of Dr. Sarika Zavre, Head of Department of Computer Engineering, AISSMS, IOIT Pune. Moving to the next slide. Yeah, this is basically the outline slide. So in the this slide will depict how we are moving in the subsequent presentation. So there are the introduction, literature survey, motivation, and all that stuff. So talking about the introduction, we all know what supply chain is all about. A supply chain is a network of relationships that enable distribution of various goods and services both locally and globally. So I am not going into the depth of the supply chain, as we all know about what supply chain is all about. There are retailers, manufacturers, and consumers, distributors, and all that. But this paper mainly focuses on how we are implementing the machine learning in the supply chain sector to support the requirements of the modern organizations. And how we are doing this? We are doing by utilizing the previous information to forecast the sales demand, recommending the products based on the customer's past purchasing patterns, and purchasing probability of the customers based on the purchasing patterns. So therefore, this paper studies various machine learning algorithms which are extensively used for demand and supply communication. Moving to the next slide. So in this research paper, we are mainly concerned with the three models. First is the sales forecasting, second one is the purchasing probability, and the third one is the product recommendation model. So how we have decided that we are gonna we are doing a research in this domain. So because there are some issues with the traditional supply chain management, and some of them include varying market conditions like seasonal weather, timely, occasionally, monthly, and product category, and difficulties in managing the inventory, reduced customer satisfaction, identifying the frequently sold items. So these issues can also be related to the specific market conditions and can be both general or user specific. So this is the literature survey. The paper titled is Machine Learning Revolutionizing Supply Chain. This paper mainly focuses on the ML regression models that are used in the demand planning more as compared to the clustering, random reinforcement learning, and classification. Our next paper is comparison study, product demand forecasting with machine learning for shop. So this paper mainly throws light on the demand forecasting that compares the algorithms like naive-Bayes, decision tree, and KNN. Among all the three algorithms, the naive-Bayes classifier obtains an overall accuracy of 58.92%, which is highest compared to the other two algorithms. So the next paper is predicting purchase probability of retail items using an ensemble learning approach and historical data. So this paper mainly focuses on the ensemble learning techniques like XGBoost, convolution neural networks, and random forest. And together they give a maximum efficiency of 87.82%. So the next paper is predictive analysis of the supply chain management using machine learning approaches. This paper classifies the need for demand sensing using various models like ARIMA, NARCS, XGBoost, random forest, and decision trees. So our last paper that we have focused in this data analytics in the supply chain management, review of machine learning applications in demand forecasting. This survey throws light on the role of machine learning applications in demand forecasting using the use of data analytics. So moving ahead, these are the research objectives of our paper. The first one is predicting the quarterly sales that we will done with the help of the sales forecasting model. And the second one is the updating the inventory according to the purchase prediction that we are going to implement using our purchasing probability model. And the third one is increasing the overall customer satisfaction by recommending the highly suitable products to the customer. So the next is the system architecture, how we have proposed a system. First, we have obtained the historical data. After analyzing the data, we have pre-processing it and splitting the data as training and testing data. In this splitting, we have used a 70% of the data is training data and 30% of the data is testing data. After that, we have selected the algorithms, and after selecting, we are evaluating the performance of the model and comparing the performance of all the algorithms for each model and selecting the most appropriate algorithm for each model. So moving ahead in the slide. So this is a dataset description. This is the sales data. It consists of 8,08523 rows and 12 columns in size. So next is a purchase probability data. It consists of 18 columns and 1233 rows in size. And the next one is our product recommendation data. It consists of 7 columns and nearly 52,000 rows in size. So now there is a data pre-processing, how we have pre-processed our data. So most of our data is in the structured format as we are fetching it from a small scale manufactured company that is a sponsored project. So it can be easily fed it to the ML model with very low amount of cleaning required. So how we are doing the pre-processing? Like we have identifying the outliers with the help of a scatter plot, box plot, and histogram. And we are doing the feature extraction and missing and null values. So moving ahead in the presentation.
Yes, as discussed before, the three models that we are proposing is sales forecasting, purchase probability, and product recommendation. Now, considering the sales forecasting, we have implemented four algorithms, which is extreme boosting, Bayesian linear regression, random forest, and lasso regressor. Here, we are comparing these algorithms against each other and evaluating on the basis of the score. Now, in the sales forecasting model, we are forecasting the future sales based on the historically provided data and predict the amount of sales accordingly. Talking about the purchase probability, similar to the sales, this also accommodates four models, which is the k nearest neighbor, Gaussian knife base, k means, random forest. Now, this algorithm basically helps in finding the purchase probability of a particular product for the organization. This will help in deciding whether the product is profitable in the market and what is its demand. Next model is the product recommendation, where we have compared two algorithms, a priori and FP growth, which generates frequent item sets for product recommendation. This algorithm will recommend the particular product based on the frequency of the demand that is provided. Now let's see the results section of these algorithms. As you can see, the table depicts the following results for sales forecasting. As we can quickly notice that the R2 score of extreme boosting algorithm is highest, which is around 0.9149. So also the RMSE, MAC residual errors are lowest compared to other algorithms. Hence, for sales forecasting, XGBoost is performing better. Now, heading on towards the results for purchase probability. Here we have graphically represented the results in the form of confusion matrix, where the graphical representation, using graphical representation, one can calculate the recall value, precision, F measure, accuracy. In our case, we found that random forest is performing highest when compared to other algorithms. Also, as we can see that the FP rate, which is the false positive rate, is lowest when compared to the other algorithms for random forest, and hence the type 1 error is the lowest. Now, let's jump to the results of product recommendation. For product recommendation, this FP growth is tree centered as well when compared to a priori, which is array centered. FP growth uses divide and conquer, whereas a priori uses DFS. Certainly, the execution time when compared to the minimum support value of 0.02 is 8 seconds for FP growth and 150 seconds for a priori. Noticeably, the amount of scans required for FP growth is also much lesser. Let's move on towards the graphical representation of the results. Now, when comparing the execution time against the minimum support value ranging from 0.02 to 0.08, FP growth, here you can see, performs much faster, as you can see a sudden increase in spike of execution time for a priori. Hence, FP growth is much faster when compared to a priori. Now let's conclude the overall paper. After studying and analyzing multiple algorithms for each model, we have best suited the algorithm for a particular set of model considering the business requirements. For sales forecasting, XGBoost is performing much appropriate compared to other algorithms for factors like R2, RMSC, MAC, and maximum residual error. For purchase probability, random forest is found to be more suitable with 90% accuracy. And for product recommendation, FP growth is ideal when compared to a priori, which generates the expected results. Now, I want to highlight that based on the environmental shifts and the data set that you have used, these results may vary, and also numerous deep learning and CNN methods for big data can be used in future to discover various multiple hidden layer complexities. Now, heading on towards the references, we have referred the paper following and which are in line with the supply chain in machine learning concepts. Thank you. Now, if anybody would like to ask questions, we are welcome.
A very good topic for using machine learning in the supply chain. What about the iOS and IoT and IIoT?
Sorry, sir.
What about the Internet of Things, Internet of Systems?
Okay, so yes, sir, we can include the IoT, but as per our case, we are not including the IoT. We can do in the future work, like we can scan the invoice bill of the customers or the businesses, retail shops. We can scan and we are analyze and extracting data from those invoice using the convolution neural networks.
Okay, because the reason I'm mentioning this is with over 25 years in 15 different countries, what I have noticed, and in fact, my research was based on the topic close to my heart, which is ERP.
Okay.
So industrial revolution has already taken industrial revolution, the industry 4.0 has taken big way.
Yes, yes.
And I fear by the time you continue this, presentations and doing your literature reviews and surveys, you might be left behind little bit slightly, and you might play a catch-up role in the race, because I 4.0 has already taken its place in multinational companies, right? If you are
Yes,
aware.
yes, sir.
The
We
other
can
point I
use,
want to
yes,
sorry.
yeah, just a minute, sir. We can use the IoT. Like I have heard somewhere that Volvo is using the IoT techniques in their supply chain to track its vehicles components.
Yes. In Bangalore also there is one or two companies which has already implemented this. Auto industry, some of them I know, whose names I don't want to disclose. In Pune here, they have also gone ahead with 4 as a pan India project. And in your presentation, I didn't notice when it comes to delivery. You have talked about sales, you have talked about purchase, you have talked about product recommendation. But what
Yes.
about the delivery?
So in this research paper, sir, what we are focusing on the sales forecasting and the 3 models which have shown you in the presentation. And in the future, we can also include the logistics part and shipping part.
Okay, no, because usually it should go in one go. When you talk of supply chain, at least you should outline the various areas which contribute to the supply chain as a whole, I would recommend, and not leave few elements aside, which make me feel like, have you forgotten, or is there no significance
No,
of
sir.
delivery?
It is not significance, like we are getting a data from a sponsored company, and what are their requirements, we have analyzed them, and after analyzing their requirements and what problems they are getting in their supply chain, we are trying to solve them.
Yeah, but when you talk supply chain, it should not be company focused. When you say small scale company which you are dealing with to continue doing your project work, because when you say supply chain, it has to be in its entirety. Sorry, you can mention those points. However, these are not of significance in the present project or organization you are associated with. You can put always a note, but you cannot leave at your will and pleasure certain elements of supply chain. You cannot define or redefine supply chain in your own terms, I believe. That's
Okay,
one thing. And
sure,
other
sure.
thing is, even because it's a small company, you may want to also, multinationals I have worked with in last 2 and 3 decades, they have various warehouses. So its supply chain is not only dependent on the vendors who are supplying or you're procuring money from, or you offloading to the subcontractors, but even the goods movement from warehouse to warehouse, which could be at geographically different location, also plays a very vital role in the supply chain management. Bear in mind that as well. It's not just the suppliers or the subcontractors or the vendors, but it's the warehouses of the particular organization also, where the sub-assemblies are being transferred from one plant to the other plant or one city to the other city, also is a major contributor of lags in terms of efficiency, in terms of material handling from one plant to the other. Okay. Other
Sure,
than
sir.
that, Very good
Sure, sir.
presentation.
We will focus on this part in the
Yes,
future.
it's a
Definitely, we will focus this.
it's a hard and very, very important supply chain management forms what you call the backbone of the operations management and the manufacturing companies. That's why I'm emphasizing so much on this.
Yes, sir.
Please
Yes,
be
sir.
careful.
Definitely, we will work on it.
Okay. Thank you.
Thank you, sir. Thank you so much.
So
Welcome.
thank you for your valuable feedback.
Welcome.